Hi everyone. Today let's talk about session 3.7, implicit differentiation. But before we go to that session, I want to review of you the theories about inverse functions, exponential and logarithmic functions. Okay, so this is session 1.3. Okay, inverse function. Given a function f is inverse if the inverse exists. Is a function f inverse such that whenever y equals f of x, then x equals f inverse of y. So inverse function is like x and y, they exchange. Okay, so what is a one-to-one function? A function is one-to-one on domain D if each of the value f of x corresponds to exactly one value of x in D, i.e., f is one-to-one on D if f of x1 not equal to f of x2 whenever x1 not equal to x2. So, what is one-to-one? For example, x cubed is one-to-one. Okay, but however, x squared is not one-to-one. Why? Because you can see there is a y value that corresponds to two x values. Okay, so and the horizontal line test says that every horizontal line intersects the graph of a one-to-one functions at most once. So we have the vertical line test. Vertical line test tells us whether the graph is the function or not. And then the horizontal line test tells us whether the function is a one-to-one or not. Okay, so existence of inverse functions. So let f be a one-to-one function on a domain D with a range R. Then f has a unique inverse, f inverse, with domain R and range D, such that f inverse of f is just the x. Inverse and f, when we composite, we also get the y back. So it's like f and inverse, when we apply inverse and we apply f, so we just get the same thing back. Okay, so this one-to-one functions, so if you can remember, x cubed is one-to-one, so we can find the inverse function. That's the cube root. Well, this is the cube root of x, right? But x squared is not one-to-one. However, even though it's not one-to-one, we can restrict to a region that is one-to-one. So we can look at x greater equal to 0. So then that piece, so we restrict to this piece, then this piece is one-to-one, then we can find the inverse function. So this is square root of x. Okay, so far so good, everybody. And next, mirror image. The graph of f and the graph of the inverse functions, they are mirror image about the line y equals x. So you can see, how do we get the cube root? Well, we take the mirror image across the line y equals x. How do we get square root? We take the mirror image of x squared across the line y equals x. So far so good. Okay, next we have the logarithmic functions. So y equals log bx is equivalent to, say, x equals b to the y. So log bx and b to the x, they are inverse function. Okay, so you can see they are a mirror image about the line y equals x. And we have some exponential rules and properties. A to the m times a to the n is a to the m plus n. A to the n times b to the n is a times b to the n. A to the m over b to the n is a to the m minus n. I have a typo here, sorry. And a to the n over b to the n is a over b to the power of n. A to the m is a to the n times m. A to the n and then to the m fruits is a to the n over m. So the m fruits actually becomes the denominator in the exponent. A to the minus n is 1 over a to the n. A to the 0 is 1 if a is not 0. But actually 0 to the 0 is defined to be 1. So this is also true when a is 0. Okay? So we also have the logarithmic rules. Log bx times y is log bx plus log by. Log bx over y is log bx minus log by. This is so powerful because, well, we will learn the logarithmic differentiation later. But you can see, well, for products, if you want to differentiate, you need to do product rule. But if you apply log, see, log split the products into sum. Well, when you differentiate sum, it's very easy. You just the derivative of sum is just sum of derivatives. And quotients, if you want to do quotient rule, there's a lot, right? But log can split the quotient into difference. Then the derivative of difference is just the difference of the derivatives. So the log functions can help us to make the derivative easier. Okay? And log bx to the y, we can put the y, the exponent, down in front. So we have y log bx. And log bc equals 1 over log cb. Why is that? Well, that is actually because you use the change of base formula. This is the change of base formula. So I had base b. If I want to change to a new base c, well then this equals to log c of x. So the x is on top, and then the old base becomes the b, but in the denominator. Okay, so this is a change of base formula. With the change of base formula, let's say then we can prove this guy. Let's say we can use the base e. Well, then this is ln of c over ln of b. Well, this is 1 over ln of b over ln of c, but ln of b over ln of c is actually ln the log cb. Okay, see, we have proved this. Okay, and then next, log a to the m of b to the n. So we just said we can move this constant down in front, can become the numerator. We can also move this exponent down in front, but it becomes the denominator. Okay. Yeah, so you can use the change of base formula and combine with this guy to show that. Okay, and then log b of 1 is 0. Oh, why is that? Remember, exponential function looks like this. And the logarithmic function is the inverse function, so it passed through this point 1, 0. So log b, actually not only the base any base, it also always passes through the points 1, 0. So log b of 1 is 0. Log b of b to the x is just x. We said log b and exponential function, their inverse function, they sort of cancel out. You just get x back. Log b is 1. So b and log b, they sort of cancel out because they're inverse function. You also get the x back. Okay. So, and then for these problems, this is about how to solve equations involving exponential terms and logarithmic terms. So I give you the solution here. So I hope that you can work on those problems and check my solutions. If you don't understand, please let me know, okay? So hopefully you learn this concepts in your pre-calculus class. So this is just like a refresh your memories. So I hope with the notes you can sort of understand, and if you don't, please come to see me. Okay, so that's the inverse function. Let's learn the new stuff. Let's come back to calculus. 3.7, implicit differentiation. Big idea. An implicit equation is an equation involving x and y that is difficult or impossible to solve for y equals f of x. For curves that are described by implicit equations, the slope of the tangent line can still be calculated by taking the derivative of both sides of the equation and applying the chain rule to the dependent variable y. This technique of implicit differentiation can be used to find the derivatives of inverse trig functions and hyperbolic functions. In our course, we'll cover inverse trig functions in 3.9, and then we won't cover hyperbolic function. but it's very similar idea. Okay, so big skills, you should be able to find the slope of a graph that is defined by an implicit equation. Okay, so some functions can be described by expressing one variable explicitly in terms of another variable. So y is a function of x. So you can see y, you have y on one hand side, and then your right hand side is just a function of x. No matter how complicated it is, but this we solve y explicitly, right? You have only y on the left hand side, and your right hand side is function of x. It could be very complicated, right? But anyway, we only see x on the right hand side. We don't see y in the right hand side. Okay? But however, some functions, but they might not be functions, be careful. That's why I put a quotation mark here. So however, some functions are defined implicitly by a relation between x and y, and they might not be functions. What is this guy? Well, x squared plus y squared equals 1. This is actually the unit circle. We know unit circle is not a function because it does not pass through the vertical line test. Okay? But however, you can solve a y. So you can solve a y. You get y is plus or minus square root 1 minus x squared. The positive one is the upper half. The negative one is the lower half. So they by itself is a function, okay? So in this case, you can still able to solve y explicitly, but some other relations like this, oops, you're not able to solve a y in terms of x. Yeah, so sometimes it's impossible to solve a y in terms of x, or solve a x in terms of y. So that's why we need the methods of implicit differentiation. Okay, so let's look at our example. Example 1, if 2x squared plus 3y squared equals 5, we want to find dy dx. Verify that 1 is on the curve, and then find the equation of the tangent line and normal line of the graph at the point 1. First of all, how to verify 1 is on the curve? Well, let's plug in x is 1 and y is 1 into the equation and see whether it is true. So 2 times 1 squared plus 3 times 1 squared, is that equal to 5? Yeah, so this is true. So 1 is on the graph. Next, we want to find the tangent line and normal line, so we need to find the derivative, because derivative is the slope of the tangent line. So how do we find the derivative in this case? Okay, so here, I'm gonna write down the steps. See, every new type of problem, we write down the steps. So it's like a recipe, we follow the recipe, and then we know how to cook, right? Do you cook? Okay. The first step, we want to take dx on both sides. Okay, sometimes you might need to use product rule or chain rule. Okay, or both. All right, and so when you differentiate, okay, remember, when you take the derivative of x with respect to x, dx is kind of just 1. But when you differentiate the y, okay, so when we differentiate the y, we need to use the chain rule, okay? So that's why it's whatever the derivative of y, and then at the end you multiply by y prime. Okay, y prime is the same as dy dx. Okay, so this is the same as dy dx. Okay, so second steps. Okay, so you're gonna separate the terms with dy dx and the terms without dy dx. You're gonna move all the terms, with dy dx to the left hand side, and move all the terms without dy dx to the right hand side. And because all the terms on your left has y prime, so you can factor that y prime, and then your y prime is just square over this guy, right? So far so good, everybody? Yeah, so you can factor it and then solve for y prime. Okay, so here are the steps. Now let's solve our example. So we take the derivative with respect to x on both sides. So d dx of 2x squared plus 3y squared equals d dx of 5. We take the derivative. Okay, derivative of 2x squared is 4x. Well, then when you differentiate the x, you don't need to multiply by anything, because the thing about dx is just 1. It's like you multiply by 1, then we don't need to write it down, okay? But when you differentiate the y, it's 3 times 2y, so 6y. After you differentiate, you need to multiply y prime because of the chain rule. So we have this guy because of the chain rule, right? So when you differentiate y, whatever you get, you need to multiply by y prime. And then the derivative of 5 is 0. Okay? See? Now, this is the term with y prime. This is a term without y prime. What are terms? Terms are separated by plus or minus. Okay? So this is one term. This is a factor of a term. Okay, so we keep this term on the left. The 4x, we move to the other side. It becomes minus 4x. Then y prime is minus 4x divided by 6y. 2 is a common factor. We can cancel the 2, and this is what we get. This is the derivative. And what's next? Oh, we want to find m tangent. Well, what's m tangent? Well, that's the derivative evaluate at the point 1, 1. So we plug in x is 1, y is 1. Oops. Then we get minus 2/3. Okay, what's next? Well then, y minus the y coordinate is 1 equals slope x minus the x coordinates. So we have minus 2/3 x, negative become positive. So let's continue. Y equals negative 2/3 x. We add 1 on both sides, so that's 5/3. This is the tangent line. So far, so good, everybody. How about the normal line? So normal line, and normal is negative reciprocal of the m tangent, so become positive 3/2. And then, do you just replace this by 3/2? No, we go back to the point slope form. So y minus 1 is 3/2, x minus 1. Y minus 1 equals 3/2 x minus 3/2. So both sides add 1. We get 3/2 x. Minus 3/2 plus 1 is minus 1/2. So this is the normal line. That finished our problem. So far, so good, everybody? Yeah, so we follow these steps. Okay, let's continue. So I hope that you can try to work on this problem, and then once you're done, you can continue to play the video and check your work, okay? So part A, we want to find the equation of tangent line at the point 2, 2. Okay, so we need to differentiate, right? So take the derivative with respect to x on both sides. So derivative of x cubed is 3x squared. When we differentiate the x, don't need to multiply by anything. But when you differentiate the y, derivative of y cubed is 3y squared. You're going to multiply by y prime. And then on the right-hand side, you are you have two things, x and y, they're both functions. So you have product rule. Well, that is the first guy prime times second guy plus first guy times second guy prime. So far, so good, everybody. Let's continue. So 4x derivative is just 4. And y prime is y prime. So what are the terms with y prime? This guy has y prime. This guy has y prime, right? Then we move them to the left-hand side. So we have 3y squared y prime minus 4x y prime equals 4y minus 3x squared. And can you factor out y prime on the left-hand side? And then your answer is the right-hand side divided by whatever you factor out y prime and left. Okay. Yes, so this is our derivative. And we want to find the m tangent, well, which is the derivative evaluate at the point 2, 2. Well, 4 times 2 minus 3 times 2 squared, 4. 3 times 2 squared, 4 minus 4 times 2. Oh, so 8 minus 12, negative 4. 12 minus 8, 4. Oh, so the answer is minus 1. So far, so good, everybody. So we know the slope, we know the points, we're ready to write down the line equation. So y minus the y coordinate of the point, which is 2, and then equals to the slope x minus the x coordinate of the points, also 2. Alright, so we have minus x minus plus 2. So y equals minus x plus 4. This is the tangent line. So do you get the same answer for this part? Yes. Alright. So let's look at the second part B. At what point in the first quadrant is the tangent line horizontal? Okay, so this is the other direction, right? We're talking about the slope and then ask you to find the x values. So tangent line is horizontal. What does that mean? Okay, so I want to summarize here with you. So this is part B. So tangent line horizontal. What does that mean? Well, it means your derivative is 0. Okay? It means the numerator of your derivative is 0. When the tangent line is vertical, oops. What does that mean? Well, which means y prime does not exist. Well, does not exist if you have a fraction or quotient, then it means your denominator of y prime is 0. Okay, in our case, horizontal, so the numerator. What is the numerator? This guy is 0. So in our case, we have 4y minus 3x squared is 0. But however, we have one equation, but we have two unknowns, x and y. How do we find two unknowns with one equation? So one equation is not enough. We need another equation. Don't forget the point is on the curve. So they must satisfy the equation of the curve. Okay, so now we have two equations. We can solve two unknowns. Do you remember how to solve system of equations? So you probably learned how to solve system of linear equations. We have two methods. One method is called elimination method. Okay, for solving a system of linear equations. Okay, so you want to match the you want to eliminate one of the variable. You want to match the coefficient to be the same. So you multiply by the LC. You multiply the equation by a number to create an LCD. So then you can subtract the two equations or add those two equations together to eliminate that variable. And the other method is called the substitution method. Okay, so which substitution method is you solve for y in terms of x and then you plug into the other equation, so you get equation of only one unknown, then you can solve that unknown. Or you can solve x in terms of y and plug into the other equation. Okay, so but here we don't have we're not having linear equations. We have higher order equations, so we can only use substitution methods. So which one we should solve for? Use the first one. Okay, and we can solve for y. So y is then move the 3x squared on the right and divide it by 4. See, we can solve for y, and then we can plug in the second equation. Okay, so we can plug in the second equation. Let's see. Then we have x cubed, y cubed. So 3 cubed, x squared cubed became x to the 6. 4 cubed equals 4xy. Y is 3x squared over 4. So far so good. So here I also calculate what is cube. So I cubed every factors in this expression. So what is that? This is x cubed, 3 cubed, 27, x to the 6, 4 cubed, 64, 4 cancel. This is 3x cubed. So let's move other terms to the left. Then you have 27, 64, x to the 6. You see x cubed minus 3x cubed becomes negative 2x cubed. So remember how to solve equations, we try to factor. So we can see we can factor x cubed. So we have x cubed 27 over 64 x cubed minus 2 is 0. So we can set each of the factor is 0. So here x cubed is 0. We get x is 0. But we are looking for the first quadrant. So rule out this case, because x is 0 is not in the first quadrant. Well, then let's look at this one. So 27 over 64 x cubed minus 2 is 0. We can move the 2 to the other side. Then x cubed is 2 times 64 over 27. We can take cube roots. Okay, so don't put plus or minus, because when you take square roots, you have plus or minus, but when you take cube roots, you only have one number. Yes. So that is the cube root of 2, 64, and 27. If you can remember what's cube root of 64, how do we get 64? We start from 4 to 4 cube, give us 64. 3 cube give us 27. So now we take the cube roots. We just get the 3 and ups. We just get the 4 and 3 back, and then times 2 to the cube roots. Okay, so this is the x. How about the y? Well, we can plug in here to find the y. The y is 3 over 4 x squared. So 4 squared, 3 squared, 2 to the 2 over 3. Whoops. 4 cancel, 1 copy, 3 and 1 copy of the 3 cancel. So we have 4 over 3 times 2 to the 2 over 3. See, this is the point, and it's in the first quadrant. So the point is x is 4 over 3 times 2 to the 1/3. And the y is 4 over 3 times 2 to the 2/3. So this is our point. So far, so good, everybody? Okay. Example 3. This is the cardioid. Okay, so we want to find the equation of the tangent line of the graph at the points 0, 2. So where's 2? Okay, so 0, 2 right here. We want to find the tangent line at that point. So we want to differentiate. Okay, how do we differentiate? You see, this guy is a composite function, so we let the inner function be u. We're using chain rule here, right? The derivative of u squared is 2u, but you actually put down a u. 2u times u prime. And then on the right hand side, on the right hand side, 4 stay there. Derivative of x squared is 2x. Derivative of y squared is 2y. But when you differentiate the y, what do? Don't forget the y prime. So far, so good, everybody. This is the first step. On the left hand side, we use the chain rule. On the right hand side, when we differentiate the y, don't forget to multiply by y prime. Okay, so we continue. Derivative of x squared is 2x. Derivative of y squared is 2y, but times y prime. Derivative of 2x is 2. Okay, so don't forget the parentheses. In this problem, you see the parentheses so important. Well, here, you can see here is kind of more complicated if you want to solve for y prime, because this guy is now a term, but inside the term some things has no y prime and something has y prime. So what you need to do is you actually need to distribute it to separate the terms. So you separate the terms with y prime, and you separate the term without y prime, and then you can move the terms with y prime on the left and move the terms without y prime on the right hand side. So but here, because it's not asking us to find the derivative, it's only asking us to find the tangent line. So we actually don't need to solve for y prime and get a formula of y prime. We can plug in the number here. It will help us much easier. So we can plug in 0, 2. So when we plug in 0, 2, what happened? X is 0, y is 2, 2 squared is 4, minus 0, x is 0, y is 2, so 2y is 4 times y prime. So y prime evaluate at 0, 2 because we're plotting in. Okay, if you just put y prime is the derivative, is a function of x and y. Okay, but here when you plug in the number, you should use the notation y prime evaluates at 0 and 2. And then we also have the minus 2, and then x is 0. Y is 2, so we have 4, and then y prime evaluate 0 and 2. And we know y prime evaluate at 0 and 2. This is exactly our M tangent. So in order to make the symbol look nicer and easier, I just use the notation M. Is that okay, everybody? So let's see. We have 2. This is 4. This is 4m minus 2. Okay, yeah, parentheses, be careful. And then on the right hand side, we have 4 times 4m. So, I can both sides divided by 8. Then this is gone. So you can divide it by 4. This is gone. Divided by 8. This is gone. Here you only have 2 left. So 4m minus 2 equals 2m. Well, both sides subtract 2m, so we get 2m, both sides add 2. So, m equals 1. So far, so good, everybody. So, m equals 1. What is the tangent line? Y minus the y coordinates of the point, which is 2, equals 1 times x minus the x coordinates of the point, which is 0. So y minus 2 equals x, then y equals x plus 2. So this is our tangent line. So far, so good, everybody? Yes. All right. So if you think I go over the problem quite fast, feel free to stop at each step and think more to control the pace. And when you have questions, feel free to print screen and ask me. Okay, let's continue. So this problem, we want to use implicit differentiation to find the derivative for the curve defined by the equation below. Well, this problem is more closely like the exam problems. Yes, I would say the same level of difficulties. So everybody, yes, open your eyes. Pay more attention to this problem. Okay. Alright, so we're going to find the derivative using implicit differentiation. We're going to take the derivative with respect to x on both sides. So the left-hand side, you see, we have a composite function with this is our u. Derivative of u to the 7 is 7 u to the 6, right? And then u prime. Let's do it slowly. Okay, we're using chain rule. U to the 7 derivative is 7 u to the 6 times u prime. On the right-hand side, 5 stayed here. Derivative of tangent is secant square. Oh, but you also have a chain rule. See? Secant x, u, secant square, u times u prime, but this 2x prime is just 2. Okay? Derivative of sine is cosine. Do we have another u? See, we're actually doing 3 different u chain rule in this step. Okay, so that's why I ask you don't write down the u here because, well, if you put a lot of u, I'm so worried you get confused. So derivative of sine u is cosine u, and what is our u? The 3y times u prime. U prime is 3y prime is 3 times y prime because you're differentiating the y. When you're differentiating the x, you don't need to put x prime there, right? But when you differentiate the y, you're going to put y prime at the end because you're taking derivative with respect to x. This guy is 1. Then dy dx is y prime. So later on in session 3.10, when we talk about rates of change, you're going to take the derivative with respect to t instead of x. So in this case, all the variable, no matter x or y, you're going to have dx dt and dy dt. So you're going to have x prime and y prime. The prime means take the derivative with respect to t in that case. Okay, so make sure you know what you're doing. You're taking derivative with respect to x or you're taking derivative with respect to t. Okay, so next steps. Well, here we continue and copy it down. But here, O is a product. So we need product rule. That is the first guy prime times second guy plus first guy times second guy prime. The derivative of 8 is just 0. Okay, so don't forget the parentheses here. So without the parentheses, it's gonna be wrong. Okay, so be careful. Don't forget your baby. And on the right hand side, 2 times 5 is 10. So 10 secant squared 2x plus 3 cosine 3y times y prime. So far, so good, everybody? Okay, next. You see, this is actually one term because it's multiplication. But in this terms, we can continue. You see, we haven't get rid of all the prime yet, so we need to continue. So x to the fourth derivative is 4x cubed. And e to the u. So here we have another chain rule with u is 5y, right? So this is like our u. E to the u derivative is e to the u times u prime, which is 5y prime. So 5y prime is the same as 5 times y prime. And don't forget your parentheses. Okay, now you see this is one term, right? But inside this term, this guy has no y prime, this guy has y prime. So you need to separate them. Yeah, you need to separate them. Okay, so how do you separate? Well, distribute. Okay, this guy times this guy is 7x to the fourth e to the 5y plus 8 to 6 times this guy. So copy down here 4x cubed e to the 5y plus this guy times this guy. So which is 7x to the fourth e to the 5y plus 8, 6 times x to the fourth e to the 5y times 5y prime. A lot of students might get lost here. It's just distributive law. So a times b plus c, what do? Is a times b plus a times c, right? Here, the idea is the same. So this is our a, this is our b, this is our c. So a times b plus c is a times b plus a times c, right? Yes. So think about more. Okay. All right. So far so good, everybody. Yeah, so think about more. And then on the right hand side, let's copy it down. So secant of 2x. By the way, don't move the 2 here. This 2 is inside the secant. Can't move it. Okay, now see, now all the terms now we're already separated. So here this is the term with y prime. This is the term with y prime. Let's move all the terms with y prime to the left hand side. So we have 7. Oh, we can actually move the 5 in front. So 5 times 7 is 35. X to the 4th e to the 5y plus 8 x to the 6, and then we have x to the 4th e to the 5y times y prime minus 3 cosine 3y times y prime, and then the 10 secant square 2x, and the left term move to the right. So 7 and 4 together is 28. X to the 4th e to the 5y plus 8 to the 6 x cubed e to the 5y. Okay, now you see, because they have the common factor y prime, you can factor y prime, and then you use your whatever your right hand side divided by this. Okay, so what is that? So y prime is my right hand side, 10 secant square 2x minus 28 x to the 4th e to the 5y plus 8 to the 6 x cubed e to the 5y divided by, on the left, 35 x to the 4th e to the 5y plus 8 to the 6 x to the 4th e to the 5y. Because we factor out y prime, then we have minus 3 cosine 3y. Ooh, and that's it for this problem. Yeah, so it looks more complicated. Yeah, it is more complicated. So I really hope that each step you only do one thing. And then do it slowly, and check your work at each step, because sometimes if you make a mistake in the intermediate step, the whatever after is gonna be all wrong. So check your steps carefully, check your work carefully. Okay, so here what do we do? We do the chain rule, and then we do product rule, and then we separate the terms with y prime and without y prime, we distribute it, right? And then we move the terms with y prime to the left hand side, the terms without y prime to the right hand side. We factor y prime on the left and solve for it. So the steps are the same as we discussed, but here we involve more rules: product rule and chain rule. And the derivatives, the functions get more complicated. You see more variations of the derivative formulas. Okay, so last example, example 6. We want to find the second derivative. So we're gonna first find the first derivative. So how do we find the first derivative? Take the derivative with respect to x on both sides. So on the left, we have first guy prime times second guy plus first guy times second guy prime. And then the derivative of 3 times 2e to the 2y, but after you're done, multiply by y prime because you're differentiating the y. Derivative of cosine is minus sine x. So far so good, everybody. And let's continue. So x prime is 1, y prime is y prime. This is 6e to the 2y y prime minus 4 sine x. So you can see here, these are the terms with y prime and these are the terms without y prime. So let's move the terms with y prime to the left hand side. And we can also factor out y prime. So I have y prime x minus 6e to the 2y. On the right hand side, I have minus 4 sine x minus y. Is that okay, everybody? So you can see I also factor out y prime because then I don't need to write one more line for this step. And then my y prime is negative 4 sine x minus y over x minus 6e to the 2y. A lot of negatives, so let me multiply by negative numerator and denominator. Then I can see more positives. Okay, and I can switch them, so 6e to the 2y minus x. So far so good, everybody. It's okay if you just want to leave it here, it's okay, but I just want to make more terms with positive. Then when I do the quotient rule next steps, I won't get into trouble because of a lot of negatives. Okay, so this is the first derivative. How do we find the second derivative? Well, the second derivative is just the quotient rule of this guy, right? So 6e to the 2y minus x denominator squared, and then we have the top guy times the bottom guy minus the top guy times the bottom guy prime. Alright. Okay, parentheses stay there. Derivative of sine is cosine. Derivative of y is y prime, right? Just leave it there. 6e to the 2y minus x minus 4 sine x plus y. This is 6 times 2, 12, e to the 2y times y prime. Derivative of x is 1. The denominator stay the same. See? Now can you see the y prime? So what is y prime? We actually already get y prime. So y prime, replace y prime by this guy. So that is Let me use both colors so you can see. So that's 4 cosine y plus my y prime. I'm going to use a different color here. 6e to the 2y minus x minus 4. So don't forget the parentheses. Make sure you put them in the correct place. Y primes, I'll leave it there. And minus 1. 6e to the 2y minus x squared. Okay, so let's just come back and change my color and put in the y prime. So this is 4 sine x plus y over 6e to the 2x minus x. This is 4 sine x plus y over 6e to the 2y minus x. And that's it. We don't need to simplify, so this is the second derivative, and we make sure all the factors we don't have prime because we already differentiated them. So this is our answer for this problem. Okay, and that's it for sessions 3.7, implicit differentiation. Okay, have a nice day. Bye.